Hi everyone, my name is Will Valida. I'm a software engineer and cloud architect, and in this video, we're going to be introducing ourselves to Kernel Memory. Now, Kernel Memory is a multi-modal AI service which specializes in the indexing of datasets through continuous data hybrid pipelines, with support for retrieval augmented generation, synthetic memory, prompt engineering, and custom semantic memory processing. Kernel memory supports lots of different data types, such as PDFs, Word documents, PowerPoint presentations, images, spreadsheets, etc. And we can extract information and generate memories from documents using large language models, embeddings, and vector storage. And then using embeddings and large language models, Kernel memory enables us to use natural language queries for obtaining answers from our data that's been indexed. We can obtain information such as citations, links to original sources, etc. Now, kernel memory is available as a web service. We can also use it as a Docker container. We can use it for plugins for ChatGPT, Copilots, and the semantic kernel. Remember, in a previous video, I talked about how kernel memory can be used as a plugin for semantic kernel, and then kernel memory can be used to enhance our AI agents. We can also use it as a .NET library for embedded applications as well. Now, before we go into kernel memory a little bit deeper, we'll talk about the differences between kernel memory and semantic memory. So, kernel memory is a service that was kind of built on the feedback received and lessons learned from developing the semantic kernel project and also semantic memory. It provides several features that otherwise we'd have to develop manually, such as storing files, extracting text from those files, providing us a framework to actually secure our data, etc. The code base is entirely written in .NET, which eliminates the need for us to write and maintain features in multiple languages. And then as a service, we can use kernel memory from any language, tool, or platform. So we can use it in browser extensions and ChatGPT assistants. And I'll talk about how we can actually do that a little bit later. Now, semantic memory is a library for C#, Python, and Java, and it wraps direct calls to databases and supports vector search. It was developed as part of the semantic kernel project and kind of serves as the first public iteration for long-term memory. The core library itself is maintained in 3 different languages, while the list of supported storage engines known as connectors kind of varies across these 3 different languages. So in this video, I'm going to show you how we can get started with kernel memory, and we'll talk about 2 specific methods that we can use: serverless mode and then using kernel memory as a web service. Now, kernel memory works and scales best when we're running it as a web service. This allows us to ingest thousands of documents and information without blocking our application. However, when we're just getting started with kernel memory, we can use it in serverless mode, and this embeds a memory serverless class in our .NET application. Now, by default, this is actually volatile and keeps all data in memory only without actually persisting it on the disk. Now, this is a bit of an example about how we can actually use serverless mode with kernel memory. And you'll see that memory serverless and memory web clients, they implement the same interface and offer the same API. So it's not like when we choose a particular mode, we're stuck with it. We can easily switch from one mode to the other. However, the difference is that because serverless mode is running inside our application, we can only use it for .NET applications. Now, depending on your scenarios, you might want this. You might want to run all your code locally inside your process, or you might want to run it remotely through an asynchronous service. So if you're using small files, you only need C#, in your application, and you have the ability to kind of block the process during the import, local in-process execution is fine. However, if you've got one of the following scenarios, you've got a web service where you want to just import data and send queries for your application to answer. If your application is written in another language, if you want to define custom pipelines and mix it with multiple languages such as Python, TypeScript, etc. If you're importing large documents that require minutes to process and you don't want to block any user interface, or if you just want to run your memory import process independently with supporting failures and retry logic, you can actually deploy kernel memory as a service. And with this, you can plug in default handlers, use custom handlers written in another language, and really leverage asynchronous non-blocking memory encoding processes, sending documents and asking questions using a memory web client. So let's see this all in action in a demo. So what I'm going to do is we'll run kernel memory in both serverless mode and as a web service. We'll import some documents and then just ask it some questions. Okay, so here I am in Visual Studio, and the first thing we're going to do is we're just going to do a really basic example of using the kernel memory. We're going to install the packages that we need, upload a document, and just ask it a question. Cool. So first thing I'm going to do is install a couple of packages. So I've got an app settings.json file, and I want to load that as part of my configuration. So I'm just going to browse and I'm going to install the configuration.json package. Go ahead and install that. Fantastic, that's installed. Cool, so now what I want to do is install the kernel memory package. So just it's this Microsoft.kernelmemory.core package. This is the package that I'm going to use, and it's going to contain all the core logic of kernel memory. There's all these other packages that we can use for kernel memory, but I'm just going to use the core in this video. So I'll just go ahead and install that. And there we are. So if I just open up my CS proj file, I can see that's already been installed for me. Fantastic. So I'll go into my program.cs file and I'll start writing out some code. So cool. So I'll just start out my configuration builder. So the config, new configuration builder. I'm going to add my JSON file. And build that. Awesome. And with that, I'll have my OpenAI key. So I'm just going to be using OpenAI for this example, but you can use Azure OpenAI among other things as well to use kernel memory. So just create a string variable for that config, and in my app settings.json file, I've got a configuration with a key value, OpenAI key. Cool. So now what I want to do is create my kernel memory builder. So I'll create a new variable for memory, new kernel memory builder, and I'm going to use with OpenAI defaults. And there's a whole bunch of things before I actually continue with that. So I can add text embedding generation, AI text generation. If I'm using Azure OpenAI, I can add those models in specifically. So there's an OpenAI config object where I can pass through things like the endpoint and the key and the model name that I'm using. But I'm just going to use the defaults for now with the OpenAI key. And when I build that, I'm going to have this memory serverless object. Cool. So there is my kernel memory builder object created. So if I just hover over the OpenAI defaults, that will allow me pass in an API key, which I've got from my OpenAI dashboard. I've done a video on how you can actually use the OpenAI key in Semantic kernel. So if you want to, if you need to know how to use a key or get a API key from Azure OpenAI, please view that video. And this will give me access to the default OpenAI models, so 3.5 Turbo and Ada 002. So that's for text generation and embedding. And then this memory serverless object, so that's just going to be an in-memory client that will allow me to upload files and kind of search for answers without depending on the web service. Fantastic. Okay, so now that I've got my kernel memory object created, what I've got is a PDF file, which I'm going to import into the kernel memory so we can actually ask it some questions. So I will await that because this is still an asynchronous method. So import document async, and that's just going to be sample km readme.pdf. And I'm going to give this a document ID of doc001. Cool. And then I'm going to var just write out, ask a question about this document. And then the question, I'm going to make this a little interactive. So that'd be console.readline. So we're able to provide some input. And then I'm going to get the answer by asking our kernel memory that question. So that's ask async and pass through the question. Cool. And then I'll write this out. So what I'll do is the question, create a new line, and then the answer dot result. Cool. And there's a whole bunch of things that we can actually retrieve from this answer or memory answer object. So if I want to write out the sources, so what sources kernel memory is using to kind of generate the answer from, just do a for each loop. So for each source in answer dot, and we should see relevant sources. That will give us a list of relevant sources that's used to produce the answer. So from there, we can just write out kind of the source name. And we can also get the link of that. So source link. And then we can also see when this document was last updated. So partitions first, and then get the last update. Format that out a bit. Cool. So we can see when that document was last updated. Let me get a little bit more real estate here. Cool. So as you can see, it's very simple to get started. So I'm building a memory using serverless mode for my kernel memory. I'm importing a document that I've got here. I'm going to ask a question. We'll write in some input to actually ask our question, and then it's going to produce an answer based on our question. Cool. So we run that. Cool. So as we can see, our kernel memory, there's a whole bunch of handlers that come as part of kernel memory. And this is kind of like a built-in pipeline that's kind of happened here. So we've generated some embeddings. We've extracted the text from our document. We've got a summarization handler ready. All of these handlers are kind of ready. And then it's gone and queued the upload for our file. Then it's uploaded our file, extracted the text out of it, assigned a petition, generated some embeddings, and then saved the records into this kind of index here. This is all in memory, so it's all volatile. So if we were using an external data source like Azure AI Search, this would actually be retrievable from a particular location. Okay, so I've got a PDF document that kind of talks about kernel memory. So I'll just ask a question, what's kernel memory? Go ahead and ask. Cool. So there's my question. So what's kernel memory? And then it's given an answer based on the document there. So kernel memory is a multi-modal AI service that specializes in efficient indexing of datasets, etc., etc., etc. And as you can see, it's given us some resources, sources as well of where it's actually retrieved this answer from. So here it's given us the source name. This is the link to the actual document in our memory storage. So again, if we were using a remote storage, this would be the actual location of the document in our data store. And this is when it was last updated. So I've just added this PDF on Monday, 29th of April, 2024. So that's when it was last updated. Cool. Cool. So now what I want to do is I want to use the web client or the web service, sorry, for kernel memory. So I can switch this from serverless to my web client, but there's a couple of things I need to do. So first thing I want to do is install another package. So the package I want is Microsoft kernel memory.web client. Cool, and that's going to allow me to connect to the memory web service to index and query any data and documents using large language models and natural language tracking sources and showing citations. So let me go ahead and install that. And there we go. So if I open up my CS project file, there it is. It's already installed. Fantastic. Cool. Now, there's a couple of things I need to do first before we write any code. So if I just go into GitHub, the kernel memory repository actually comes with the kernel memory service web client that you can use to work with kernel memory as a web service. So what I need to do is actually configure this. So run this .NET run setup in the service directory and then run it. So I'm going to jump into my terminal and let me go into the service. There we are. And I'm going to write .NET run setup. Cool. So this is going to take me through kind of some on-screen prompts to create and edit my configuration file. And we can interrupt this as many times as we want and run it multiple times to modify the settings. So first thing it's going to ask me is how should the kernel memory service run and handle memory documents ingestion? And then for this, I'm just going to use the web service with asynchronous ingestion handlers. So make sure I'm in there. Protect the web service with API keys. This is just a demo, so I don't need to do that. So I'm going to go ahead and say no. And enable the open API Swagger doc at swagger index.html. Yes, I want to do that. Which queue service is going to be used? We're just going to do simple queues for now. And we're going to accept the default directory, so that'd be underscore queues. Where should the server store files? Again, we're just doing this in memory, so simple file storage, so I'll do that. And again, accept the default directory. We can do this to Azure Blobs if we really wanted to. Which service should be used to extract text from images? We're not going to be doing that in this demo. We can do this with AI document intelligence, but I'm not going to do that. When importing data, generate embeddings or let MemoryDB class take care of it. Yes, we want to generate embeddings, so we'll select yes. And then when searching for text and or answers, do we want to use Azure OpenAI embedding model or OpenAI embedding model? I'm going to use my Azure OpenAI embedding model for this. So I'll click OpenAI. So again, you need to provide a endpoint. I'm going to use my current endpoint there. And you also need to provide an embedding model deployment name. I've got a deployment model for embedding, so I'll use my current one. And you also need to provide an API key, which I've done so already. Cool. And then when searching for answers, which memory database service contains the records to search? So we can use Azure AI Search, Quadrant, Postgres, Redis. But for this, I'm just going to use Simple Vector DB. This is going to use a volatile storage in memory. So again, it's only suitable for tests. But you can manually edit the app settings file that this generates to persist on disk later. So I'll just accept the default for now, and also accept the default directory. Cool. And then when generating answers in synthetic data, which text generator should be used? Again, I'm going to use Azure OpenAI. Again, I've got the defaults already set up for me because I've used this before, but you need to provide an endpoint, a deployment name for chat completion. So if you've got a chat completion deployment model, provide that along with your Azure OpenAI API key. And then you can provide a certain log level that you want to set. So I'm just going to use information for now. Cool. So that's our service all set up. So now what we need to do is actually start our service. So in the same directory, I'm going to type .NET run. And that's going to go ahead and start my service. Cool. So now what I should be able to do is open up localhost at port 9001. And there we can see the API docs for this. Cool. So we've got a number of endpoints available to us. So uploading documents, retrieving indexes, deleting indexes, documents, querying particular indexes, asking, searching, getting status for an upload. So say if we're uploading large amounts of documents and we need to host this on a separate process to our application, there's an endpoint here for getting the status of that upload of those big or those large documents. Cool, so let's go back into Visual Studio and let's edit this code a little bit to use the web client instead. So what I want to do is I'll just delete all of this. Actually, not delete it because I'm going to upload this to GitHub later. So I'll actually comment this out. There we go. Cool. Let's work a little bit further down our program.cs file. So first thing I need to do is I need to connect to the memory service that's running locally. So I'll create another object for our memory, and this time it's going to be a memory web client. And then from here, I can pass in an endpoint. If I was going to put authorization to it or protect that endpoint, you can see there you can provide an API key header for authorization, or the default is authorization. But we're not going to do that because we've already we haven't configured that. So I'm just going to put in my local host and then port 9001. And that's going to connect to my memory web client. Cool. So now what I want to do is import this sample KM README file into kernel memory. So again, await memory import document async. So that's going to be the sample KM readme.pdf file. And I'm going to give it a document ID of doc001. And since we're going to be ingesting this, I'm just going to simulate, it's not a large document, but I'm going to just add a little bit of an await here just to make sure that the document does get imported or uploaded properly. So while we can do this, await memory is document ready async, and then I can actually pass in the document ID. So while that is being uploaded, I'll just add a bit of a delay. And I won't make the delay too long, from milliseconds. There we are. Cool. So once that's uploaded, we'll ask another question. What I might do Just copy and paste that, uncomment that. So we'll ask a question, and then we will write out the answer. Copy and paste that. Sorry, lots of copy and pasting, but cool. So we'll actually make this a little bit more interactive. We'll get the input into the console, and then we'll ask the question. Cool. So let's give it a run. Cool. So it's waiting for the memory to be or the document to be ingested. Cool. So ask a question about this document. So I'll ask again, what's kernel memory? And there's the answer. So similar answer from before. So kernel memory is a multi-modal AI service that specializes in efficient indexing, etc., etc., etc. Cool. So I'll just exit out of that. So as you can see there, rather than doing what we were doing before, is actually running kernel memory in a serverless mode. So that was in process inside our application, where it would upload the document in memory. This is now using an external web service, so we can actually run the kernel memory in a separate process. So say if we have larger documents, or we're trying to ingest a large amount of documents, we're running that as a separate process. Here we've kind of added in a bit of simulation for waiting until all the documents have been uploaded before we ask questions. But say if this was a UI, we could go ahead and actually still run that UI, and the memory ingestion process would be non-blocking. There wouldn't be we wouldn't have to wait for that process to begin before starting the UI. So if you're streaming documents, this is a good example of when you'd actually opt for using the kernel memory web service rather than the serverless option. Cool. So that wraps up this video. If you like this video, give it a like. If you have any questions, please pop them in the comment section below. And if you'd like to see more videos on kernel memory, don't forget to subscribe. I do a bunch of videos on kernel memory, semantic kernel, semantic memory, Azure OpenAI in general, Azure AI in general. So if you like that kind of content, don't forget to subscribe for more. No matter where you are in the world, I hope you're having a great day, and we'll see you all next time.